Hello, my name is Russell Picho, and today's date is January 11th, 2026. And this is the molecule for week 14, group 14. So the molecule that we have is C7H14O2, and the molecule, and I want to first start off by calculating the degrees of unsaturation. The formula is 2n plus 2, and n represents the amount of carbons there are in the molecule. So I do 2 times 7 plus 2, which gives us 16, and that is the amount of hydrogens that are available for a saturated amount of 7 carbons. So I do 16 minus 14 divided by 2, and that gives us 1 degree of unsaturation, and that tells us that there's at least one double bond or some sort of cyclic ring in the molecule. So starting off with the IR, I noticed that there's a peak at roughly 3000, indicating that there is a CH peak. I also don't see a peak at 3200, like a broad peak over here, or 3200 or above, indicating that there is no OH peak. Then I also see a peak right here, roughly around 1720, 1750, and that tells us that there is a carbonyl, so a C double bond O peak in this molecule. I also see a peak at 1500, indicating a carbon-carbon single bond, and I also see a peak here roughly at 1250, indicating a C-O bond. And now going to the C13 NMR, I see a peak here at roughly 170. And anything above a 200 is a ketone or an aldehyde. And since we know there's a carbonyl portion up here due to the 1750 peak in the IR, we know that we have eliminated the ketone aldehyde because we don't see a peak above 200. So a peak between 160 to 180 indicates that there is either a carboxylic acid or an ester. But we also know that there was no OH peak in the IR, so we've also crossed out carboxylic acid, leaving us only an ester. So now we know that there's an ester in the group, and we see something here very far downfield compared to the other portions, other 4 peaks over here. This is the O of the something that is some sort of carbon that is bonded to the O portion of the ester. But we'll explain that. We'll figure out what part of the carbons is attached to it by looking at the H and the R. So looking at the H and the R, we see 9H, and obviously no carbon can hold 9 hydrogens, so we know that there is some sort of symmetry in the molecule. And we see that there is 9H, so we know that there's 3 methyl groups that are very symmetrical, and that instantly tells me that there's a terp-butyl, because a terp-butyl is connected to a carbon that has no hydrogens, which is also why it gives that singlet appearance, because that 3 methyl groups, 1, 2, 3, is connected to a carbon, connected to some other carbon, or an oxygen, we don't know yet, that gives it the singlet. And that is so upfield on the portion at 1.25 ppm, indicating that it's far away from the carbonyl ester portion. We see something slightly more downfield, roughly at 2 ppm, with the 3H. So we know that there is a methyl that's also given a singlet. So we know that it is attached to, we know that is more downfield, so we know that it's attached to one part of the carbonyl. We don't know yet if it's the carbonyl, or if it's the O part of the ester. And is also singlet. We also see something a peak at 4 ppm. It's a 2H, which is indicating a CH2 group, and is also giving a singlet. But since it is the most far downfield, we know that that is connected to the O rather than the carbonyl of the ester. We know that's connected to the O because the O is more electronegative, indicating that it is making the hydrogen of the CH2 more partially positive, making it more downfield. So we know that this CH2 is connected to the O, and in this 3H, this methyl group is connected to the carbonyl aspect of the other side of the ester, CH of the carbonyl. And we know that this 9H, because it's so far upfield and is so far away from the carbonyl or the O part of the ester, we know that this CH2 is connected to the NH, because obviously this is missing one attachment, and that attachment is the carbon that connects the terp-butyl. And so we see here, like I said, this 80 ppm in the and the C13 is indicating that there is a it is the CH2 group, that is connected to the oxygen, making the carbon more partially positive because the oxygen is pulling it away because it's super electronegative. This one roughly at 32 ppm is indicating the methyl group right over here, the methyl group that is attached to the carbonyl side of the ester. And then these three peaks are representing the tert-butyl, because since they're so far upfield, that is farther away from the carbonyl or the ester or the O part of the ester. So for that reason, usually the C13 and H-NMR kind of go hand in hand, nearly as this it represents that, this represents this, and then this represents these three. Once again, to go over all of this, we see a peak at 3000 at CH, indicating a CH bond, 1750 indicating a C-double-O bond, which also with the 1 degree of unsaturation that we indicated, gives us that this C double bond O is the 1 degree of unsaturation that we figured out. This 1500 peak is C, so carbon-carbon single bond, and at 1250 is the carbon-oxygen single bond. We also see here that 10, 22, 28, since they're very, very close to each other, we know that that is the methyl part of the tert-butyl. And at 34, it is the carbonyl, is the methyl connected to the carbonyl side. At 82, we know that it is the CH2 connected to the O, and the difference between the jump between the 34 to the 82 is because the oxygen is really pulling, is really making the carbon partial positive. And the real big jump at 170 is the carbon in the ester of the carbonyl. And once we have here, once again, we have a 1.25 ppm. We see a 9H integration with a singlet, and it is a tert-butyl because we see 1, 2, 3 methyls connected to a carbon that is connected to the CH2 group, but because this carbon has no hydrogens, that gives it the singlet. Because the multiplicity is nearby hydrogens plus 1. At 2 ppm, we see integration of a 3, which is a methyl group, and it's also giving a singlet because this methyl is connected to the carbonyl side, and this carbonyl is connected to the O, making it the ester. Because this ester portion right here doesn't have a hydrogen connected to it, we know that gives it the singlet because it's 0 hydrogens plus 1, giving it the singlet. And at 4 ppm, we see 2H plus 2H. So we know that is the CH2 connected to the O, and then on the other side is connected to the tert-butyl carbon that, as I mentioned up here, that has no hydrogens, giving it also that singlet. And this is my proposed structure. Thank you.